Hi, welcome back. Now that we've completed the installation, let's go on to the class. Now we're going to talk about data types. The basic data types in Python, there's four that we're going to talk about today: integers, floats, strings, and booleans. So in Python, on the left here, let's go through them. Integers, or ints, abbreviated, are used to store whole numbers. They can be positive numbers, negative numbers, or zero, without decimal points. So that's an integer. A float, or floats as they're sometimes called, are used to store numbers that have decimal points. Strings are basically STRs, are used to store text or a sequence of characters enclosed in single or double quotes. So you can have a full sentence with numbers in it, spaces, capital letters, doesn't matter. As long as it's enclosed in quotes, you're good. That's a string. Booleans, or bools, are used to store true or false values. I like to remember booleans like binary is 0 and 1. Boolean starts with a B, so true or false. It's very similar kind of concept. So over here on the right, let's talk about the built-in data types, the explanation, and the example of a variable. So the built-in data types that we're talking about: integers, any whole number with decimal points; floats, numbers that include decimal points after the decimal; string, collection of characters representing a text-based value such as a message, a name, a street, whatever you want it to be, something descriptive; a boolean, the concept of true or false values. So let's talk about an example of a variable. So variable equals value. So all the variables here have a name. It's always in lowercase. Band members, class counts, daily special. You notice all of these are lowercase. You can include numbers in variables. It won't reject it, but it mostly we use letters with underscores. Now variables think of it as a drawer in memory where you can store something, and what you're going to store is a value, and that value can change, which is why I think the changing value is why they call variables. So it's not constant forever. It's whatever is put in there last. So band members equals 4. The variable band members has equals 4. So think of it as a drawer, and on that drawer there's a label that says band members. And inside the drawer, you have the 4 band members. Let's say it's the Beatles. So you have Paul, Ringo, George, and John. They're all holding up a sign. Each one has, let's say Paul has a 1, Ringo has a 2, George has a 3, and John has a 4. They're holding it up. I'm giving you a kind of a silly example so you understand. These guys are standing inside the drawer in memory. It's a 4. And then you close the drawer, it says band members. That's stored in memory. But later, let's say you added a band member to the Beatles, and you had 5 band members. Let's say Yoko. So now when you open if you tell it in the code, band members equals 5, when you open the drawer, you'll see Paul, Ringo, George, and John, and Yoko in the drawer. Now, everybody knows Yoko wasn't a Beatles band member, but that's another story for another time. So class count is 22. So that's a variable is class count, and the value is 22. So on a float, we have the daily special, which is your drawer where you're storing it, what you're going to store in memory, and we're storing $4.99. So daily special at Denny's is $4.99. They never make it $5. They always take a penny off to make you think you're getting a great deal. Sounds cheaper, $4.99 than $5. So what's in the drawer is $4.99. The watts, same sort of thing, 1.22. What just notice is there's decimal points after each of these. Average height, 9.666. So it doesn't matter how many decimal points are after it, the computer will recognize it as a float. And these aren't interchangeable when you're doing mathematical operations. You either use all integers or all floats. You don't mix data types when you're doing calculations. Data types don't mix. So you always try to make data types, they kind of mingle together as the built-in data types. So string, teacher's name, my name is Luke. It's spelled with a capital, so I want you to notice that a string can have capitals in it. Just like the state and my state, there's two words, put an underscore on the variable, and the value is Arizona, and it's capitalized and it's in single quotes. It can be double quotes or single quotes, but for this training, we're going to stick with single quotes going forward. Street address has a number in it and a period, but it'll take it. So what happens is if you store that in the drawer teacher name, when you open the drawer, you see the word Luke in there. Same thing, if you open the drawer of my state, you see the word Arizona. If you open the drawer of street, you see 72 North Canyon Road. The last one we're going to talk about data type is Boolean, which is the true or false. And the reason I wrote it twice and wrote true and false, it can't be both at the same time. It's one or the other. Think of it this way. If you're writing code and you're on the third line of code that you're writing, and you say over underscore 10 days underscore, like over 10 days with the underscores is equal to true, that's great. So it'll hold the value of true in memory until you tell it something different. So if you did that on line 3, maybe line 10, you want the value to change from true to false based on some logic or something you're trying to do in your code. You can do that. But as you run the code will remember whatever was the item that was saved last. So it can be both true or false for the same variable. Same thing with the machine is on. The machine is on. The machine is on true. That means it's running. The machine is on false. That means it's not running. So it's off. So it's used in a lot of ways to make programming, to do automation, things like that. Integers and floats are used for calculations and counts. So these are all data types are important because they determine the type of data that can be stored in a variable, how that data can be manipulated. For example, if you add a string to an integer, Python will raise an error because they are incompatible data types. That's what I was talking about before. These different data types, you can't mix them. So you really need to understand properly how to use data types, and it's crucial for running efficient and error-free code. Now, let's start to look at working with examples of each data type in Python that we just discussed. So what I want you to do is pay attention on the screen. I'm going to put a pointer. Just a second. So when you see these 3 dots and these 3 dots, that's just before and after the text. I don't want you to copy the 3 dots when we go into coding. Just copy the data between the dots. So let's see if I can do an example. So now after you've downloaded Anaconda Navigator, we're going to go to the screen. There's Jupyter Lab and Jupyter Notebooks. So if you scroll down, you'll be able to see this launch button. Just launch Jupyter Notebooks. And be patient. What it'll do is it's going to look for Chrome on your machine, and it's going to launch Jupyter Notebooks within Chrome. We'll give that a second. So now you should be able to see in Jupyter Notebooks will come up. So we were previously, when we downloaded Python, we were on this website. So this new tab will appear. And I already have my different folders here that I have different projects I'm working on. What I want you to do is come over here to New and click on New. And a new tab will appear. So again, was Launch. And then a new tab will appear automatically. And then we click on Python 3. So another tab appears, and we're basically going to put a new window to do coding. So I've made that full screen now so we can see what we're doing. And while that's coming up, so now this is our area that we're going to be working in Jupyter Notebooks to do the code. So you can go to the PowerPoint, and then we would copy this section, but don't copy the 3 dots, just copy the section. And then go back to the Jupyter Notebook, and we're going to paste it here. Now this is a kernel, and there's a little circle here, and it's open. We're going to put paste, and we're basically saying name is equal Alice, message is equal hello world, and empty string is that. So these are different things we're storing. So if we hit run, there was no errors. Nothing happened though. All we did is this is a variable, this is a variable, and empty string is a variable. In this variable, we have stored Alice with a capital A. It's within quotes. So this is the text we're storing. And here's some more text we're storing, hello world. And here's an empty string. So text is called a string, as we had discussed earlier. So let's do a print statement, all lowercase, open the parentheses, and say name. N-A-M-E. And then we want to print the name. So if we say return, it should say Alice. So then we run it. It says Alice. Let's print the message. And we hit run, and it will come back and say hello world. And let's do the same for the empty string. Now notice that print and then empty string, and notice that it is a variable. We don't use spaces in variables. We use the underscore. And the empty string, there's nothing in between the quotes. So if we run it, we should come back with nothing. But you'll notice there is a line here. So you can see there's nothing there. But if we go back to this and we say empty string, and we put some spaces in here, 3, 4, 5 spaces, and then we also say print empty string underscore string. What you'll see is if you hit run this, we did get a space here, but if you highlight this, you can see there's 5 empty spaces there. This is an important concept to know. Empty strings with no spaces, like here you can't see anything if you hover over and you put your mouse click, but here we can see those empty spaces. So sometimes in programming, you're going to want to put empty spaces within your code. But the most important thing here is the examples of variable, which is like a drawer where we're putting something into memory. And what we're putting into memory for here is these strings or text files. String is always as quotes in the front and the back. So now let's go back to the other screen. So we have this screen, this screen. So now let's go back to the PowerPoint presentation. And as you see here, let's try the booleans. So let's go, we're going to copy that. We're not going to copy the 3 dots. And then we're going to come back here and we're going to go to our code and we're going to say is raining true or false. Now remember, when we say print, it's always lowercase, P-R-I-N-T, and you open and we'll say is raining, is raining. So if we say print is raining, the only thing that will print is the word true because we stored it as being true. So if we run this, it should return true. Same thing goes for is sunny. So if we just put that into memory and say print is sunny. And you can do two at the same time. Print as cat. So we're going to, if we do this like this, when we run it, it should give the same, what's stored in the variable is sunny, stored false, and has cat, the variable stored is true. So it should return, once we run, is sunny false, and on the next line it should say true. So that covers booleans. So let's go back again and go to the PowerPoint, and let's try some integers. And remember, integers are whole numbers. So when we look at whole numbers, we are storing for x is 5, y is 10, or minus 10, and z is 0. So if we say print, and we say x, and we say print y, and we say print z, because each of these integers that are stored, there's no decimals, so it's not a float, it's an integer, which is a whole number. So print x, print y, print z, if we hit return, we should read 5, minus 10, and 0. But let's do some calculations. Again, it always has to be lowercase, print, and the x plus minus 10 y. So if we say x plus minus y, we should have negative 5. So it should say 5, 10, 0, and negative 5. Let's run it and see what it says. 5, minus 10, 0, negative 5. We can always, and we don't always have to have, because we know these are stored in memory, so we can continue to use it. So you say print, and then you can say x plus z, and then minus y. So that's going to be 5 plus 0 minus 10. So let's see if that's 15. So that's 15. So you can start to understand how to do different types of calculations. So let's do y divided by x, which should be minus 10 divided by x. So I would assume that's minus 2. Minus 2. And you notice because we're dividing, you get a float, which is minus 2.0. So let's go back and take some other floats and do some examples with these. So print a plus b. Now, actually, let's do all x plus b plus c. Now, each of these are floats, so we can add floats. Float plus a float plus a float works. If we had a float plus a float as an integer, it would give us an error. So let's try this. So 3.14 plus 2 is 5.14 plus 5, 4.64. So let's go back to the PowerPoint. So in Python, integers and floats are numerical data types. Strings are used to represent text, like this. And booleans are used to do true and false statements. Note that strings can be written using either double quotes or single quotes, and empty strings can be created using a pair of quotes with nothing in between. So that kind of covers data types. Watching today. If you like what you saw, please like and subscribe. We'll be posting weekly videos for Class 1. If you want to jump ahead and join on the website, go to the link below. It's basically the 12-week training challenge website. And once you get at the website, you can scroll to the bottom and you could do the 14-day trial, which is absolutely free. It has Class 1, it has the PowerPoint presentation, course requirements, and all the slides. Hope you enjoy it. Please keep in touch, and we'll see you at the next video. Love you all. Bye-bye.